I myself, Nasim Fatima, Assistant Professor, Department of Physics, Government College of Autonomous, Kalburgi, wanted to present a micro teaching on this online SRC refresher course of mathematical science conducted by UGC Malviya Mission Treatise Training Program, conducted by Aligarh Muslim University, Aligarh. My topic is I have to give a brief talk on nanoparticles. What are nanoparticles? Nanoparticles are the particles whose material properties lies in the range of 1 to 100 nanometers. And I have chosen the nanoparticles among that for my topic, optimization of tuning of the photolysis properties of europium doped borate glasses by co-doping with silver nanoparticles. Optimization of silver nanoparticles was synthesized. This co-doping of europium dioxide with silver nanoparticles was synthesized by conventional melt quenching method. The dopants used were europium dioxide and silver nanoparticles, where which was doped with the glass composition from 10 to antimony bismuth and sodium oxide ranges from zero point 0 to 0.1, 0.51, 1.5 molar concentrations for two different samples. One was for europium oxide, another was silver nitrates. And the characterization techniques by structural, XRD, and TEM measurements were done. In this structural properties, we have studied the behavior of the nanoparticles doped with this antimony bismuth and silver nitrate. First, we have seen that in europium concentration from 2.1.5, 1.5 to 0.5 ranges, as the intensity goes on increases at the level of 40 to 50 degree, we have seen the peaks, and silver nitrates also we have got the same thing as the intensity goes on increases. So around the range 40 to 50 we have found here the peaks, and it was identified that the optimized europium oxide concentration was 1 molar concentration, and this is the TEM measurements. The structural properties has been studied by TEM measurements, and TEM measurements from this we have got the particle size and spherical particle size were increased, which were in spherical shape, where size was in ranges between the peak what you have seen as the frequency goes on increases particle size at the range 6 to 9 nanometer, where we have seen the spherical size of particles. When silver nitrate concentration also we have seen that as there is was the nanometer particle size increase in nanometer, we have seen that the same spherical size particles have been formed under the range of 10 to 40 nanometers when silver nitrate concentration photoluminescence intensity of europium transitions has been improved at 0.6 molar concentrations. Suddenly the identity was quenched at 0.8%. And we have seen that these micrographs of silver nitrate were emitted with borate glasses. And this was the migration of the nanoparticle was studied by Ostwald's ripening process, where we have seen that two different molecules combine to form a coalesce to form one molecule when two different molecules coalesce together at, with different molecules. And from this, we conclude that the optimization of silver nitrate concentration with different borate classes in europium dioxide and silver nitrates, we have seen that as the concentration goes on increases to 1%, the europium transition improved up to 0.6 molar, and suddenly the intensity quenched at 0.8%. With the increase in the silver nitrate concentration, we have the radiative lifetime measurements where it has been said energy transformation of europium and ion to silver nitrate ions. And we have calculated the judo Olfit parameters. From the judo Olfit parameters, the radiative it has been studied at the estimated emission cross section, quantum efficiency was more efficient, and this suggests that the silver nanoparticles embedded with borate glasses has wide applications in the field of optoelectronics, photoelectronics, photonics applications. Thank you.